Okay, does anyone have a question with what's on the board? Okay, so let's clear the decks. I'm going to clear it slowly, so if you have a question, you can stop me. Okay, okay. I think we're done with 8.1. Let me make sure, take a look at this. I'm pretty much sure we're done. Yeah, we are. Okay. So we're done with 8.1. Let's knock this out. Let's go to section 8.2. Okay. Okay, good. All right, let's go to section 8.2. So let's do dividing. Radicals. And we're just going to walk down the line. How do we simplify a radical? How do we add and subtract a radical? How do we divide a radical? How do we multiply a radical? We're going to go through every operation. Okay, and at the end, we'll go how to solve a radical. And pretty much that's going to be the game plan for every new thing you learn. We'll go through logs, how to add them, how to multiply, how to divide them, and then how to solve them. And pretty much that's just the way your life is going to be in math. We're going to teach you a new function and teach you a new way to process it. Okay. So let's do this first one. So let's go 4 plus. Excuse me. And then let's do 8. Okay. Now this is going to come up every so often. We'll simplify a problem. At some point, we'll get to here. Okay. So what I want you to do first is simplify that 12. Okay. You can do it either by looking at the prime factors, or you can do it by looking at the perfect squares. I don't care which one you do, but go ahead and simplify that radical 12. So my index is equal to 2, and I can either pull that out, or I can look at this and say the square root of 4 is 2. So now we get to a situation where we get 4 plus 2 square root of 3 divided by 8. Okay. Now there's sort of two ways of attacking this problem. Okay. So I'm going to put a big or here. One way of attacking this is to factor out the GCF. So you ask yourself, what number divides into 4 and 2? And that answer is 2. This times this turns into that. Oh, sorry, it doesn't. This times this turns into 4. 2 times square root of 3 is, right? There's a multiplication there. So you go, what number divides into 4 and 2? And the answer is 2, right? Just like if you had something like this, and I asked you to pull out the GCF, you go, oh, 2 plus x. It's the same thing, except we have a square root of 3 instead of the x. Okay. And then what we do is we simplify this. 8 divided by 2 is 4, so we end up with like that. Now that's one way to attack it. My students usually like this other way better, but this sort of tells you where this concept of simplifying comes from. Okay, we cannot simplify it if there's an addition in between. We can't just cross this out and cross that out because you have addition. You have to turn it into something that's separated by multiplication. Okay? Yeah. The other way to ask yourself is, what number divides into all the coefficients? What number divides into 4, 2, and 8? Okay. So what number divides into all the coefficients? And that is 2. So then what you do is you divide everything by 2. And you get the same answer. Now you only do this is because these things are separated by a multiplication. If everything was separated by a multiplication, just like we had in our last section, then you would do this thing where you would treat this separate from that and just do just simplify this fraction. Let me give you guys one to try. I'm just going to erase this top. Okay. So I want you to work on this problem.
Professor, just have a quick question on the one
Sure.
you did. We don't write 1, so for the last answer, it's like 2 plus, we don't write 1 after that.
Oh, okay. So let's say you're saying like this.
Yes, exactly. Yeah.
Okay, so if you had written that, I wouldn't take a point away, but I'm guessing XYZ would. So technically, 1 times square root of 3 is just square root of 3.
Just leave it off, the answer.
Just leave it off, yeah.
Got it.
Yeah.
Thank you.
Yeah. Now, normally, when I'm grading this by hand, I don't take the points away because you naturally will stop doing it. And sometimes in the beginning, it's nice to have that one because you're thinking 2 divided by 2 was 1 and just leaving that there. But I'm guessing that the programmer from XYZ isn't that doesn't give you that leeway. Okay, so do this one. Simplify this right here. That square root of 18. Right. Think about this 4, 9, or 25 divided into 18. So we're going to get 6 plus square root of 9, square root of 2. 6 plus 3 square root of 2 divided by 3. Okay. Now ask yourself, what number divides into 6, 3, and 3? And that answer would be 3. So we're going to divide each one of those by 3. And then we're going to make it pretty. And that'll be your final answer like that. Okay. Now, you know to use this technique when you have an addition or subtraction in between things. Most of this section, however, will be on a single radical. Okay, now, if you get confused on this section, the video for this section is one I did. So all the stuff I do from now on is in that video. Okay? Okay, now, this problem can be given you one of two ways. It can be given to you like this, or like this. Okay? So the first thing you do is combine. So if they give it to you like this, first combine the radicals. Now you can only combine it if they have the same index, but in this class, in every class you take, they'll always have the same index. Now what you do is now simplify the inside. So simplify the inside, you should get 4 over 25, and then you should get x squared. Now, once you do that, you can break these up. Simplify this, and simplify this. Right? Tell me what the square root of 4 is, what the square root of 25 is. Tell me what, and then simplify that x squared. Okay. So square root of 4 is 2. Square root of 25 is 5. And then x squared divided by 2. When we divide it by the index, it pulls it out of the radical. Okay, let's try that again. So let's do cube root 16x squared y 10 over, actually let's make it 40, not 16, but 48. And then over here, let's make it 3x 8 y squared. Okay, so do the same thing I did over there. Combine them and then simplify on the inside. So I have 48x squared y 10 over 3x8y squared. Okay. 48 divided by 3 is 16. Okay. Now I have 8 more x's on the bottom. If you go, how many more x's on the bottom do I have? I have 6 more on the bottom, and I have 8 more y's on top. Okay. So then let's break this up into 2 pieces. I'll break it up over here. Y to the 8 over x to the 6. So this group of 3 2s becomes 1 2 there. And we divide that by 3. Then we have x6. We divide this by 3. Okay. When we divide by the index, it pulls it out of the radical. And now we have 2 cube root of 2 y, 2 remainder 2 over x squared. And the remainders go on the inside. So I get 2, that y squared, the x squared's on the outside, and then cube root 2 y, and this 2 comes from here. Let's take a picture.
Professor.
Go ahead.
So I have 2 questions.
Sure.
In the beginning, how come you did when you combine them, how come you did cubed instead of squared?
Oh, because the original problem was cubed. That was the original problem. So
okay.
Whatever the index is from the start, you just keep it all the way through.
Mm-hmm. And also at the end, where did you get the 2y squared from?
The 2y squared. Oh, over here? Like this line here?
No, at the very bottom.
Oh, the 2y squared. Okay. So let me put in orange. This 2 comes from here. This 2 comes from here. Okay. This y, the square, so the y gets broken up into 2 pieces. This y squared goes on the outside, and this y to that remainder 2 goes on the inside.
Oh, I see.
Okay, so basically, this tells me how much is on the outside, and this one tells me how many y's are on the inside.
Oh, okay. Thank you.
Thank you. Anyone else have questions?
Yeah, Professor, I do. On the left, the x squared, is it just, how come it disappears?
The x squared over here?
No, further left.
Oh, over here. Oh, okay. I'm trying to simplify this.
Okay.
So what's going on is that I'm treating this like 3 separate problems.
Okay.
So I'm saying I want to combine these 2. And the easiest way, because these are positive numbers, you can just say, do I have more x's on the top or more x's on the bottom? You go, I've got more x's on the bottom. I've got 6 more. So you're just doing an 8 minus 2. When because of these problems, you're guaranteed that they're positive. You can just sort of say how many more on top or how many more on the bottom. That's usually easier for students.
So you're just subtracting it?
Yeah.
And you're keeping it at wherever there's like a higher number?
Exactly.
Okay.
Okay. Let's try one more. We got a decent number of questions on that, so let's do one more just like this. I'm going to leave this up there in case anyone else has questions. So we'll start with it combined. So let's go 48. And then we'll go x 10 x y squared y 8, like that. Okay, we'll say simplify.
Professor?
Go ahead.
Did I understand right that there are two ways in which you how to solve this kind of problems?
Oh, wait, say that again. I couldn't hear you. Can you get closer to your microphone?
I'm saying, did I understand right that there are two ways to solve this problem, and we choose however to solve it?
Well, in terms of simplifying the 24, there's two ways. But in terms of simplifying a division, we always use this combine it, simplify it, separate it.
Okay. Thank you.
Okay, so we go there, all right? And then for 24, it's equal to 6 times 4, 3, 2, 2, 2. So now I have 3, 2, 2, 2, x to the 9 divided by 2, and y to the 6 divided by 2. So I'm going to pull these out. So those two 2's turn into a 2. And then I get a square root of 6x, 4r1, and then y3. Okay. Now, this tells me how many are on the outside. This tells me how many x's are on the inside. So I have 2x to the 4, 6x, y cubed like that. And then we're done. Okay, so 8.2 is done. Okay. So let's run to 8.3. Okay, now 8.3 is weird. It's important. It's going to show up a lot in calculus, and it's a way to connect radicals and exponents. Okay, so let's look at 8.3. Okay. And this one is rational exponents. Now, by rational, we mean fractions. Give me a second. Let me close one of the doors. Sorry, my wife was making bread. She's one of those people who learned how to make bread during the COVID. So she's just making bread. She has a mixer on. Use the mixer in our bedroom. So she's like baking bread now in our bedroom because that noise is annoying. Okay, let's look at this puppy. All right, I left it up there for you guys to be stressed out. Let's think about it. Okay. Now we've actually dealt with something like this before. I'm going to erase this. In the past, where I told you to simplify, let's say 10. In the past, when I told you to simplify, what would happen is you'd go, oh, that's equal to x to the 10, and then we divide by the index. Now, this right here is the index, and then the numerator is the exponent. So we could rewrite this as a radical. We could rewrite it like this. So that 3 is the index. Well, let me write it a little bit easier. So this one is the exponent. This one is the index. Okay. So we could rewrite it like this. Okay. Well, let me put that in red. Like that. Now, some of you are wondering, why didn't you put the 2 over here? You could, and it would still work. But in math, if you have 2 choices, you always want to make your number smaller before you make it bigger, because you'll make fewer mistakes. Okay. Now, just know that you should learn some of the most common cubes. Cube roots. So cube root of 1 is equal to 1. Cube root of 8 is equal to 2. Cube root of 27 is equal to 3. Cube root of my mind just went blank. 64 is equal to 4. Cube root of 125 is equal to 5. So just know that these are the most common ones. The book will go up to probably 6 or 7. So let's see, what is the cube root of 6? Cube root of 216 is 6, and cube root of 7 is equal to 343. I usually make my students memorize up to 5. Okay. So the cube root of 8 is 2. And then 2 squared is 4. Okay. So let me give you one. Let's go.
Professor,
Go ahead.
how do you determine if like the example on the top left, that the exponent 2, not the left side, the exponent 2 would be outside on the very outside, or it would be inside on the 8?
Always make it on the outside.
Okay.
Always, it just makes your life easier. This is, I specifically gave this example to show you why. Okay, so this one is the exponent, and then this one is the index. Okay, so I'm gonna show you why outside is always better. Okay, because both ways actually work. So we get my index is 2. And then you have 3 like that. And then you go square root of 81 is 9 cubed. I go, what's 9 cubed? 9 times 9 is 729. Okay. Now that 9 times 9 wasn't very much fun, but it's very doable. But if we went the other direction and we did this, you could do that, but you would go 81 times 81 times 81 is equal to square root of 531,441, which is equal to 729. So just in life, even though you get the same answer, if you have 2 choices, always make your number smaller before you make it bigger. It just makes your life easier. It's easier to do 9 times 9 times 9 than it is 81 times 81 times 81, especially if they don't give you a calculator. Let's take a picture of this. Okay, now let's start with just some of the brute force homework questions. Okay. So I've already given you the whole shebang for this class, for this section. Let me just get you past some of your homework. Okay. So one of them will be write y to the 1/6 as a radical. So go ahead and write it as a radical. Okay. So you'll go y 6, 1, which is equal to the 6th root of y. Okay. So that's one question. And then they'll ask you to go backwards. Write y to the 1/4. I'm sorry. As a fractional exponent. Most books call it a rational exponent. I think your XYZ calls it a fractional exponent, which is probably easier to understand. So the way you want to think about this is that even though it's not there, there's an exponent here, and that exponent is a 1. So you can write this as y. That's my exponent. That's my index. Okay, yeah. Okay. Now, just know that these all work also. All our exponent rules work. So let's say I have something like this. Most of you are comfortable going 5? And I'm like, yeah. And the reason why you got 5 is because you added the exponents. Okay. So just know that we have the same situation with fractional exponents. Okay. So if I have 64 and I have 1/6. Okay. All you're going to do is add the fractions. So go ahead and walk your way through there. So 64, I'm sorry, 1/6 plus 1/6 is equal to 2/6 is equal to 1/3. Okay. Okay. Now go ahead and turn that into a number. Remember, this is your index. Remember, this is your exponent. So you get cube root of 64. Then we get the 1 over here. So then that is 4 to the 1 is equal to 4. Okay, so let me give you another one. Let me give you okay, so let me give you 64. 1/3 over 64. I'm sorry. 2/3, 1 over 6. So when we have something that is x3 over x squared, that turns into 3 minus 2. So you're doing a subtraction. You're doing this minus this. So go ahead and see if you can do it. Okay, so we have 2/3 minus 1/6. I should write that here. Okay. Now my lowest common denominator is 2. So I get 4 over 6 minus 1 over 6 is equal to 3 over 6. Okay. So now I have 64 and a half. And go ahead and write that as a radical. Okay. That's my exponent.
Professor.
Go ahead.
So the base is unaffected by any change in the exponent when finding a common denominator?
Yes, unchanged. Just like over here, right? When I subtract the 3 minus 2, nothing's happening to the base. Same thing here. Nothing's happening to the base. Right, so then we go like this. 8 to the 1 is equal to 8. Learn it the first time I explain it with just a clear head, then you don't have to spend a lot of time trying to figure it out. So let's come back at 10:25 and we'll finish 8.3 and we'll see how much of 8.4 we can get done. We might get a decent amount of 8.4 done. These sections are all pretty kind of short and sweet, so hopefully we'll get a lot of these done. Okay. Okay, let's do this last little bit, and then we'll start on to 8.4. Okay, yeah, 8.4. Okay, so right now we're still in 8.3. Now, there's a little subtle thing that we have to deal with. Okay, so let's start with what we know. Okay, so just remind yourselves what the answer to that is. We said that this negative and that 3 are not connected. So we get negative 3 times 3, which is negative 9. And over here we get negative 3 times negative 3, which is a positive 9. Okay, so we played that game over and over and over. Okay, now, and then in the previous section, we went over this. Just try it. Let's just see if you remember which is which. Now, this one here is very much like that one there. That negative is on the outside. It's not really connected to that 64. So this should be a -8. Sorry. Now over here, because the inside is negative and because this is even, this is not a real number.
Professor?
Go ahead.
Will we be covering imaginary numbers in this class?
Yeah, we will.
Okay.
Yeah, it's like 2 sections, 3 sections away, 2 sections away. It's coming. Okay. Now this one over here turns into negative cube root of 64, which is equal to negative 8. Okay, so now we have these problems. Okay. Now, just to remind yourselves, do this problem, do this problem. Yeah, do those 2 problems.
Professor, the last one should be -4, right? Not -8. It's
Oh, -4, yeah, thank you. Thanks for catching that. Yes. Okay, so now do these 2 problems. Thank you, thank you. This one here again. Now, this one here says change levels is equal 1/9. And then I texted everyone what your grade is right now. So far, I haven't had to curve any of the exams. I think the fact that it's open book, open notes, we're getting a lot of A's, which is fine. But we're getting more A's than usual, mostly because I usually don't do an open note, open book exam. I usually give you the same amount of time. So I haven't needed to curve anything yet, but if we do need to curve it, I'll curve it if the midterm and the quiz 3 are really bad. But so far we look to be okay. And then if your name's not on there, I dropped you from the class. Okay. So if you're dropped from the class and you don't want to be dropped from the class, please email me. I can get the instructions from the registrar to have you re-enrolled. I just dropped you because you didn't take quiz 1 and quiz 2, and I didn't want you to have a bad grade on your transcript without even trying. So if you don't find the last 3 digits of your student ID on that thing, please contact me, and I will I can find the instructions of how to re-enroll you. Okay. Okay. Now for this one here. That negative is not connected. So now we're doing the same thing we did over here, but it'll be negative. Okay, and then this problem and that problem are exactly the same. This negative is not connected. Sometimes after you do this problem, you mix it with this problem. But remember, you only change levels when when the exponent is negative, not when the base is negative, not when you have a negative in front of the base. Okay. Now, let's go back to what we've been doing. Let's work on this problem. Okay. This is my exponent. This is my index. All right, so let's review what we're doing, and then we'll walk ourselves down this little bit of confusion. So this is a 4. My index is a 2. My exponent is a 3. So this is equal to 2 cubed is equal to 8. 2 times 2 times 2. Okay, now we're all set up to do this last little part. So let's work on work on this, work on this, work on this, work on this, and work on this. Okay, now, so this one is like this one. What we need to do is change levels. And now that became positive. And then this will then turn into, which is equal to 1/2. Okay, so it's the negative exponent that tells you to change levels. Now, over here, this negative and that 4 are not connected. So this will turn into a negative. So the square root of 4 is 2. Okay, try working on this one. Sorry. If you guys hear all that, they're in my attic. Okay, so let's look at this now. Now, this negative is inside, so it's going to be inside the square root. And when we do this, we see if this is even and that's negative, we see that this is not a real number. Now, over here, we see that, okay, I have a -8 on the inside. But since this is odd, we can't have an answer. Okay. Now we only deal with this negative being inside the radical when we have this parentheses. Otherwise, the negative is on the outside. Now let's look at this. Okay. So that this negative is on the outside, and this tells me to change levels. And then when I change levels, my exponent becomes positive. And then what I do is change it to a radical, but it's in the denominator. So the last three sections, they have a lot of small little problems like this. So this is sort of your guide to all of it. This is the key page. Okay. And then the last little problem. If I have an exponent of an exponent, I get x2 times 3 is equal to x6. So in this section, they'll give you something that looks like this. And all you do is multiply the fractions. So we have x 3 over 4 times 5 over 7. So we have x 15 over 28. Okay. So let me give everyone a second to copy that, and then we'll go to section 8.4, which is adding radicals. We might finish it, we might not. We'll see. Okay, let's get going. Sorry. So let's clear the decks. Okay. Now let's get going. Here we go. Okay. So we're going to go section 8.4. Adding radicals. Okay. Now, understand that the rule for adding and multiplying are always different. So let me do multiplying first. It's 5. Now, when we look at this problem, even though it's not there, these are not Siamese twins. They're not connected. These are actually all separated by a multiplication. Okay? So we can move things around. Those things that are similar can be next to each other. Okay. Now we have this rule that said if things are together, separated by a multiplication, we can break them up. But we can also go in the opposite direction. So the easy way to think about this is the inside times the inside, the outside times the outside, right? 2 times 5, 3 times 6. Okay. Now what you want to do is you want to simplify this. So go ahead and simplify it. Okay. Does 4, 9, 25 divide into that? Or you can use the prime factors. So you have 10 square root of 9 square root of 2. This is equal to a 3. So now I have 30. So the easiest way to do this is go in outside times the outside, inside times the inside, and then simplify. So let's try another one like that. Okay. So let's go outside times outside, inside times inside. Now, 14 times 21 is some big, ungodly, awful number. Right? Square root of 294. I had no clue whether 4, 9, well, 25 doesn't, but I have no clue if 4, 9, 49 divide into there. So what I like to do if the numbers are really big is just use the prime factoring. I'm sorry, 2 times 7. 7 times 3. So if the numbers are big, just take the prime factors. See, over here the number was small, 3 times 18, but you could have done 3 times 2 if you wanted to and pull out the 3. So over here, I'm just going to take prime factors. Because when I'm dealing with big numbers, I don't want to check whether it's divisible by 4, 9, or 49. So then I can pull this out. And then I have 10 times, and then this 7 comes out. Square root of 6 is equal to 70 square root of 6. Okay, so that's how you do multiplication. You multiply the outside with the outside, the inside with the inside, and then you're going to simplify. Okay. Now, addition is always combined like terms. Whether it's exponents or polynomials or radicals, it's combined like terms. It's this game that we always play. So if I say, if I have 2 cats plus 4 catfish plus a cat, and I ask you to simplify this, say it in a way that's easier for me to understand, you would say, well, I have 3 cats and 4 catfish. We cannot combine the cat and the catfish because they're not the same thing. And if we have no number in front of the cat, we assume 1, that there's just 1. Okay. Now, we call this combined like terms. Right? The things that are similar, combine them, but they have to be exactly alike. Now, so let's say I give you something like this. Now, you can only combine the things that look exactly alike. Look at what comes after the number. So after the number, this has an x to the square root of 3. Over here, I have a square root of 3, and that's exactly the same as this. So I have 2 of these, and I have 1 of these, because when there's no number in front, just like the cat over here, we assume that I have only 1 of these. Think of these as objects. So I've got 2 of these objects and 1 of these objects. So in total, I have 3 of these objects. This and this are not the same thing. They have to be identical in order for me to combine them. This is a cat and that's a catfish. Okay. Now that's the bulk of what we're doing in this section. So let's say I give you something that looks like this. Okay. Before I do the combine like terms, the first thing I want to do is simplify each of those radicals, right? So simplify each one of these and then combine the ones that are the same, that are similar. Okay, so this is square root of 4, square root of 3. Okay, so I'm just looking for the perfect squares now. If you had done the prime factors, you'd get exactly the same answer. So this turns into 2 square root of 3 plus 3 square root of 2 plus 2 square root of 5 square root of 2. Oops, I'm sorry, 5. So then I would get 2 square root of 3 plus 3 square root of 2 plus 10 square root of 2. Now look at everything that's identical and just combine them. Okay, so this is different. These two are the same. So we have 12, 3 square root of 2, and then we're done. All right, let's try another one of those.
Professor,
I think you did something wrong.
Did I? Which one? I could have.
Towards the end of the problem.
Uh-huh. Oh, 13. 10 plus 3. Is that better?
Yeah, and the radicals is supposed to be 3.
Oh, yeah. I just copied it wrong. I flipped them up. Is that my dyslexia? Okay. All right. Thanks for catching that for me. All right. Now, let's try another one. Let's try square root of let's go 200 plus square root of trying to think of what numbers haven't I used. 98 plus 3 over square root of 24. Okay, go for that one. So we have 100 times square root of 2, 49 times square root of 2, 3 times 4 square root of 6. So we have 10 square root of 2 plus 7 square root of 2 plus 3 times 2 square root of 6. So we have 17 square root of 2 plus 6 square root of 6. Okay, now let's do foiling. So let's look at something that looks like, see, where's your only picture? Yeah.
Professor,
Go ahead.
from the last example, what if I simplify the square root 24 into square root 12?
Mm-hmm.
And
Okay.
then square root 2.
Okay.
Would
So
that
you're
be
asking
wrong?
that. You're asking that. Okay, question. Now, see, the problem is this: the only one that works is 4 square root of 6 because the square root of 4 is 2. If you turn this into 2 square root of 12 or square root of 3 square root of 8, they won't work because I don't know what the square root of 3 is. I don't know what the square root of 2 is. So the key when you're doing this is you're looking for these specific values. You're saying, does 4 divide into it? Does 9 divide into it? Does 25, 49, or 100? These are the only numbers you're looking for.
I see. My thought was that because the other two terms, we have square root 2, that's why I make it into square root 2.
Yeah, but the problem is that's not an integer, this right here.
I see.
So then we still can't, we can only combine it when we turn that into an actual whole number.
Thank you.
No problem. Okay, so we're going to FOIL this puppy. We're going to say this times this, this times that. And then we're going to say this times this, this times that. Okay. Now I want you to simplify each term. Okay. So multiply these together, then simplify. Multiply those together and simplify. Simplify. That one you can't simplify. So let me just be more clear. Okay. So we'll multiply the inside with the inside, the outside with the outside, and then your job is to simplify each one of these radicals, if you can. Okay, and then, I'm sorry, the command will be multiply, not simplify. Okay. So you have 2 square root of 9 square root of 2 minus 10 square root of 3, right? 4 and 9 don't divide into here, but 4 divides into there. Like that. And then you have 2 times 3 square root of 2 minus 10 square root of 3 plus 2 square root of 3 minus 5 square root of 2. Okay, so now you have 6 square root of 2 minus 10 square root of 3 plus 2 square root of 3 minus 5 square root of 2. So the things that are similar, combine them, right? You can combine this one with this one, and you can combine this one with that one. Okay. So 6 minus 5 is 1 square root of 2, and minus 10 plus 2 is minus 8 square root of 3. And then you're done. And because this sort of has everything, it tests whether you can multiply radicals, whether you can add radicals. This is almost always on the exam. So let's try it again. So multiply. Now, this can sometimes be given like this, where it's hidden like that. So I'll do the first step for you, then you'll expand this. So go ahead now and FOIL that. Okay. So we get 5 times 5 plus 5 times 2 square root of 3. So that takes care of this times this, plus 5 times 2 square root of 3, and then this last one is plus 2 times square root of 3, 2 times square root of 3. So go ahead and multiply everything. Outside times the outside, inside times the inside. So let's go 25 plus 10 square root of 3 plus 10 square root of 3 plus 4 square root of 9, right? Outside times outside, inside times inside. Now I can combine these. These go together. I've got 10 of these and 10 of these, so now I have 20 of them. So I have 25. And now I can add the 12 and the 25. So let's do one last one where we deal with a really big index and really big numbers. Okay, so this one looks like cube root of 7 times 3 plus cube root of 245, like that. Okay. So now this turns into 3 times cube root of 7 plus cube root of 7 times 245. Now what I would do is I would go find the prime factors because, well, first of all, these are big numbers, and because the index is 3, we don't know how to do that. So whenever you have a big number like that, always divide by 2, 3, or 5. Finding the prime factors of a big number is actually an unsolved problem. It's how all our passwords are saved. So normally what they do when you have a really big number is they make it divisible by 2, 3, or 5 until you see a number that you recognize. That's usually the trick. Right, so go ahead and find the prime factors of that. Okay. So you'll get 5 and 49, and then 7 and 7. So now you're doing 3 cube root of 7 plus. We have that original 7, and then we're going to bring all these other things up. We have this other 7, this other 7, and this 5. So go ahead and simplify that, and then check whether you can combine like terms or not. Okay, so we can pull this out. So then this turns into 3 cube root of 7 plus 7 times cube root of 5, and then we're done. These two things are not the same thing, so we can't combine them, and we're done. Okay, so we covered a lot. We covered 4 sections. Tomorrow we're going to cover 3 sections, so, hang in there. We've got 3 more sections to go, and then we got one last really bad week, and then finals week usually isn't too bad because we're spending all the time with doing review over and over and over, just drilling for the final. Okay, so even though you may not have passed the first 2 quizzes, if you get 75% on the final, I'll just pass you. Okay, hang in there, everyone, and I'll hang out if anyone has questions.
Professor?
Go ahead.
So we aren't going to be learning new material on finals week?
Maybe on Monday. We're one day behind where I want to be. So we may learn some stuff on Monday, but what I'm going to try to do is the things that are really straightforward that don't take a lot of repetition, those are the things we're going to do on Monday. I'm just going to save them for that week.
Oh, okay. Thank you.
Mm-hmm.
Professor, do we have a class on Friday?
No class on Friday. So just tomorrow, and you got an extra day to study for your midterm.
Thank you.
Mm-hmm.
Professor? I have a couple questions from yesterday's homework from 7.2.
Okay.
Yeah.
Do you wanna text them to me, or do you want to show them on the screen?
Oh, I can just show you. Yeah, because I wrote them down.
Okay, great. So let me see. Let me let's see. Is it? Yep. All right. Go ahead. Turn on your camera, and then let me look at your video. All right. I can see. Okay. Good. All right. Leave it there. So let's write them all down first, and then I'll do them.
Okay. Thank you.
Sure. Okay. And then y minus 1 over 4 y minus 1, and then minus 4y plus 5, and then 7 minus
24y
24.
minus 16y squared.
Thank you. Okay, and then what are the other ones?
And here's the other one.
Okay. 4 over 3x minus 4 plus 3x plus 28 over 16 minus 9x squared. Okay, perfect. And then before I start these, does anyone have any administration stuff that you need me to deal with? Just quick questions. No? Okay, let's knock these out. So I'm going to erase this. Okay, so let's do this. Let's do this one first. This one's a little easier. Okay. So over here we have 4 over 3x minus 4 plus 3x plus 28 divided by 16 minus 9x squared. Okay, now the first thing I want to do is I want these to change positions so that my x's come first. Then I have minus 9x squared plus 16. And then I want to pull out a negative 1 GCF because when I factor this, I want this to be positive. Right, so I'm going to pull out a 1. Like that. Okay. So what's going to happen is that I'm going to look at this and I'm going to go, a positive times a negative is negative. Okay, and then I'm going to factor that. Okay, now I did a few things here. I multiplied these together to make sure that this will be negative. And then what I did was I put a parentheses around here because since this is negative, it's going to distribute on top. Now, what I need to do is get a common denominator. So what they have in common is this 3x minus 4. They both have this in common, but I'm missing a 3x plus 4 on this side. So I'm going to add that. Okay. Then I still have my minus. And then I get 3x minus 4, 3x plus 4. Okay. Now, the important thing is that this minus is going to distribute. Okay. So I'm going to just erase it to here. And on top, I'll get 12x plus 16. And on the bottom, I should get minus 3x minus 28 over and then let's combine like terms on top. I get 9x minus 12 over, and I might be able to simplify it. So I'm going to try pulling out a 3 for my GCF. So I'm going to get rid of that. And I have 3. And I'm done.
Okay, thank you. I think my original mistake was that I didn't distribute the negative.
Yeah.
I'm
This
gonna
right
go
here?
back and work, yeah, and see what I did wrong just to make sure. But yeah,
Okay.
thank you.
Okay, we'll do this other one too. Do you need time to copy?
No, it's okay. I got it.
You okay?
I need
All right.
time. I need time to copy.
Okay,
Oh.
okay. No problem. You tell me when you're done, okay? And then I'll go to the next one.
Professor,
Go ahead.
if I got 100 on the first 2 quizzes, do I have to do the third one?
No. Well, you want to do the third one because if you say the majority of the questions that are on the final are from the third one.
Okay,
So
thank
you only want to do it because remember I told you that so if you go of the 3 quizzes, which one has the most questions? Quiz 3 that's on the final. And then if you ask me, well, where are you going to get the questions? From the practice, quiz 3 and quiz 3. I'm just going to say I'm going to limit my questions to just those questions.
Oh, okay. Thank you.
Yeah. So the whole idea behind it is that I want you to make your mistake on the quiz, and then I want you to make your mistake on the quiz. So then when you take the final, you recognize it, like, oh yeah, that's the one.
Okay, thank you.
Okay, so let's try this other one, right? And there's a really kind of nasty, mean thing that's going on over here. So let's reorder that. Okay. So I'm going to rewrite this as y minus 1 over 4y minus 1 minus 4y plus 5, but I'm going to put the y squared first. Okay. Now I know I've got to factor this, so this needs to be positive. I'm going to pull out a negative 1 again. And then when I do this and this, these two will cancel and become a plus. Now, I wish I was good enough to do this in my head, but I'm not. So let's X factor this puppy. So I have 24, 16 times 7, negative. And then I have 16, 16. And since this is a big number, I'm going to look at the prime factors. 2, 2, 2, 2, and 7. And I have to do a subtraction. So I kind of see it. If I split it this way, I can sort of see 28 minus 4. So minus 428. And this looks like 4y over minus 1. And then this one looks like 4y over 7, which is good because then I have something that's right from right there. Okay. So this turns into 4y plus 5. Now my negative is already gone because I multiplied it with that negative, and I now have 4y minus 1 and 4y plus 7. Okay. Now these two are the same, so I've got to add the 4y plus 7 over here. Okay. So now I have y minus 1 over 4y minus 1, and then I have 4y plus 7, 4y plus 7, and then I have plus 4y plus 5 over the same thing. Okay, now, the tricky thing here is you have to FOIL this. So you now have 4y squared plus 7y minus 4y minus 7. Let me make sure I did that right. 4y squared plus 7y minus 4y minus 7. And then this is a plus, so I don't have to distribute anything. 4y plus 5 all over 4y minus 1, 4y plus 7. So this turns into 4y squared plus 7y minus 2 over 4y minus 1, 4y plus 7. And I'm guessing that we may be able to X factor that. Let's try it. That's 7, that's minus 8, that's 4y, that's 4y. So we get 8 minus 1. So then this turns into 2 over y. So now I have y plus 2 over 4y minus 1 all over 4y minus 1, 4y plus 7. And then when I cross these out, that's what I have left. Wow, that's nasty. What a horrible teacher assigned that.
Thank you so much.
No problem. Anyone else have a question? Okay, I'm going to leave this up there for you guys. Okay, so those of you who would still want a copy, it's up there for you. Okay, so hang in there, everyone. you.